on the microphone. Okay, guys, welcome to the second last talk for tonight. We're gonna start off that with Urban Etter. He's working at Swiss Radio and Television. That's SRF. He has about 10 years of experience of web development. He's gonna talk about front-end performance, where it matters. Enjoy the talk.
Okay, thank you. Well, first of all, welcome to the Front-End Performance talk, and thank you for all being here in this room. First, some slides about me. You may have heard about urban legends or urban myth. You may even know a band called Urban Species. My name is actually Urban Etter. Sorry about that. Yeah, as they already said, I work at SRF, which means Swiss Radio and Television. I worked there as web architect, and more importantly for this talk, I'm part of the front-end team there. All right. Oh, my Twitter handle, UrbanC, so if anybody's interested. Now, performance is a huge topic. I could talk about cache invalidation. I could talk about vertical scaling versus horizontal scaling. I could talk about database clusters, but I won't do that, don't worry. So people who have left can now come back. I could also give you some advices for creating single-page web apps, like Gmail or something. Or I could give you some advice to get some really small microseconds out of your JavaScript. For example, this one by joining an array instead of concatenating. But yeah, I won't do that. We'll talk, however, about some good practices I think are worth sharing. Some traps I ran into and maybe you don't have to. And finally, I will show you some code. I could also call this talk Front-End Performance for the Craftsman, because I think it has a lot to do with craft. And I will talk about performance, why performance matters. I will talk about the loading process, and when we have the loading process, why it's not good to block it. Then some words about deferred loading of JavaScript. Then about the browser cache, some good parts and bad parts, some tools, and finally a bit about DOM manipulation and a recap of everything. So let's start with the first topic, performance matters. There is a lot of slides and a lot of talks already on why performance matters, so I want just to outline two quotes. One is from Google. What they did is, I think some years ago, they introduced a delay of 100 to 400 milliseconds to their result page. And what they found out that the number of searches per user dropped by 0.2 to 0.6%. Now, this doesn't seem a lot, but if you have as many users as Google has, then it's a lot. And if you also think about all the money they are losing because of that, so it is a lot. The second quote I want to show you is from 37 Signals. It's a company in Chicago. They did Basecamp, probably some of you know that, and they did a new version, and in this new version they wanted to have or one goal of the new version was performance, and they want to have, they call it the instant sensation. When you open a book, you already see the next page, and they want to have the same instant sensation. And then they say to reach that, your request needs to take less than 100 milliseconds. So that's not a lot, but yeah. But actually the most important point I want to get across is that performance is a feature. It's actually a feature like there would be a feature like a new slideshow on your web page. If you think about performance as a feature, it's also clear that it takes some effort to get it right. It doesn't come for free. And it's a feature which may also conflict with other features, like reduced complexity, because a lot of time when you do something for performance, you have to add a lot of code, sometimes very complex code. So you add a lot of complexity, which in turn decreases maintainability. And it may even conflict with security, because when you want to have your password algorithm check your password as quick as possible, it's not a very secure algorithm, because passwords algorithm should be slow, so to work well against brute force attacks. Yeah, as you can see by the vast amount of talks in the internet, it's a very complex feature, and it involves every discipline in web development. It involves the design, it involves front-end development, back-end development, system engineering, testing, architecture. It involves really, literally anything or anyone who does something with the web. So, now having this out of the way, let's go to the loading process. Now, I'm just doing this very shortly. Most of you probably already know this, but the key to front-end performance and know where you can attack this beast or change something is to understand the page loading process. Now, this is how it would look if the browser and the server would chat using iOS. And the browser would say, hey server, my user wants to see srf.ch, and then the server returns it, and then the browser says, oh, there is a CSS we are needing, and the server gives it back. So in reality, this would be a lot faster, especially if I would have to type. And there are also a lot more files. This is actually the view of our front page at srf.ch. And every row here is one of like a discussion between the server, well, not really a discussion, but conversation between the browser and the server. If we zoom in this big image, we see 3 timing points. The first one is how long it took to fetch the initial HTML. So after this, the browser knows what he has to load. The second timing point is the DOM ready, when all the HTML is in place and the browser basically knows how to render it. And the third one is when the loaded event is reached. The loaded event is at this time, the spinning wheel in your browser disappears, so this is the perceived performance from your user. And it's only reached when all the images are loaded. Okay. Further, you can see from this graphic, you could think that the browser first, when he gets the HTML, you could think, okay, I need 50 images here, so I request all the 50 images parallel, but the browser doesn't do that. That's because there is a restriction in part of the HTTP standard. The HTTP standard says you should only have 2 parallel connections per host. This is because HTTP should scale. So if the browser really would do that, fetching all the 50 graphics at once, we would have a problem with our servers. But the modern browsers allow 6 parallel connections per host. There is even, I think, IE 10, which allows 8 parallel connections. But yeah, most of browsers allow 6 parallel connections per host. Okay, Now that we understand this loading process, we shouldn't block the browser. Now this is how, at least I did it about maybe 2 years ago. I have the head and the body, and in the head I have the JavaScript and the CSS. The problem with this is that the JavaScript loading process blocks the browser, because the browser first has to fetch the JavaScript, then go through everything, parse it and execute it, and then goes on. It has to do this because in the JavaScript you could do nasty things like document.write, which would basically throw out everything the browser has already rendered. So there are two solutions for this problem. One is to using the async attribute. Async is like this, and it basically tells the browser, okay, don't worry, I won't mess up with document.write. Just load the JavaScript, and when you have time, parse it and execute it. There's the second preferred solution is actually to put the JavaScript at the end of the body tag. This is because the first solution doesn't work with all the browsers. There is another attribute called Deferred, which works for older IE versions, but you still would have to check the browser versions. So the easiest way to do that is put your scripts just before the closing body tag. All right, now some words about deferred loading of JavaScript. The idea is that you don't need all the JavaScript of your web page all the time. An idea or an example here is this web page. It's a web page of a pretty popular news show here in Switzerland. And what you can see here is for every day you have one of these rows, and then there is a calendar which you can go further back. Now, you could think that, most probably not all of the users will go back in like 2 weeks ago and want to watch the news from 2 weeks ago. So you could think, okay, maybe I could load the JavaScript needed for the calendar when I click on it. Now, we have here a little bit problem because it's on hover, this calendar stuff. So the next thought would be, okay, I could load it when I hover over it, so when the user puts the mouse over it. But then we have always a delay on hovering, because the browser has to put or open an HTTP request, load everything, and then parse it. So there is always a delay and not really this instant sensation we want to have. You could go further and think, okay, there is a time frame between loading the page and until the user really clicks on this calendar thingy, because there is some time the user needs to figure out where the calendar button is and figure out what he really wants to do. So you could use this time to download the needed scripts. But here you add a lot of complexity, because now if the calendar doesn't work, you don't know if the problem is in the script of the calendar or if the problem is in some of the loading scripts or whatever. And so you will always need more time to fix this, or your colleague will need a lot of more time. So here again, performance is a feature, so it may be worth it if you, for example, if you have do like Gmail or whatever, then it's definitely worth it. But I found that in my day-to-day job, it's most of the time it's not worth it. Yeah, unless you're creating a single-page application. I actually did that in a former project. I did a very kind of clever framework where you could just put a CSS class an element, and then it would load all the needed JavaScript. But in the end, it turned out to be actually slower than like just loading everything up in front because of the overhead of the HTTP requests. So yeah. But this doesn't mean that all the deferred techniques are bad. There's actually this deferred image loading, which we are using at this page. This is a podcast overview. We have about 170 podcasts, and each of these podcasts has this image. So when you remember back that the loaded event, which makes this spinning wheel disappear, just is here after all the images are loaded, then it would take 170 images to get loaded until you have this spinning wheel disappeared. So yeah, this would be not a good performance. So we used lazy load jQuery plugin. Luckily for us, there is for almost everything you have a jQuery plugin, and what it basically does is it defines an area like the viewport and some additional pixels, which is I think 400 at the moment, and with images which are outside this area, it replaces them from the image source with a placeholder, and then what the script does, it checks for resizing the viewport or scrolling, and if the image slips down, it does the opposite. All right. Now about browser cache. There are some good and some bad parts. First to the good ones. If you put all of your JavaScripts into one file and tell the browser to cache it, then the browser only has to download it once. Now this sounds like very normal, but if you have like a normal site with a lot of pages, like srf.ch, all the JavaScripts get downloaded at the first impression or at the home page, and then when you click on the next page, as a normal user hopefully does, the JavaScript does not need to be downloaded again. So JavaScript is free for the rest of this day. So that's nice. So that means also, like the example I gave you before, it's better to have like one big request with a lot of maybe some kilobytes of JavaScript than to have a lot of small requests. That's actually the same idea with CSS Sprites. CSS Sprites is probably more known technique. The idea here is that, for example, we have these 6 radio station logos, and instead of having all the images requested with one HTTP request, have one image, one big image containing all the small logos. And then put it in the background and use the CSS to get the right logo. Now, for this, CSS and image composition, there are a lot of tools. I'm sure you know of some of them, but it's a feature, and it's a lot of complexity you are adding here. Because, for example, if you need to exchange a logo, maybe because of some colors are slightly changed, then you cannot just exchange one image. You have to update this whole big CSS sprite. And also, for example, if you want to increase the margin of the list items of the radio stations, you may have even to change the CSS. So you get performance, but you trade complexity against it. And actually, right now, at the moment, if you go to srf.ch, you will see that it's not a CSS sprite, but maybe we should do that. But it's actually not my responsibility to as a developer, but our product owner. In our case, it's a product owner. Maybe in your case, it's a client which has to decide if this added complexity and reduced maintainability is worth the performance gain. Okay, now to the bad parts. I'm sure you all have been there. You change your CSS and you change it to this awesome background color, and then your client doesn't see it because the browser cached the CSS, and you have to tell him to keep calm and clear the cache. We actually shouldn't have the client to know how to clear the cache. What we should do is use versioning to version our CSS and JavaScript. The easiest way to do that is to just add a parameter like v equals 12, and if you change something in the script, you just increment this number to 13, which doesn't have any impact on the JavaScript, but tells the browser to refetch everything. At SRF, we have a small backend component which does this. We have a template language and a template operation or function, which we have at the bottom, just before the closing body tag. And then we have an ini file where we can specify all the JavaScript files we want to have included. And then there is this render include. This is pseudocode, but basically what it does is it looks at all the images which needed to be included, gets the latest timestamp, and compares it with the last run of this render include. Now, if there is a newer JavaScript file, it concatenates all the files it needs to, and it packs it, and then creates a new file name, which is actually an MD5 hash of the newest timestamp, and then saves this file to the file system. And it only returns this script language and script include tags, and then this file name. So yeah, like this we can always be sure that the browser cache of our user is up to date. Okay, then I would like to show you some tools which you can use to measure front-end performance. There's like the most popular one, I think, is Wiselow from Yahoo. It's a Firebug plugin, and it gives you this nice grade, and it has all these tips for making a website faster. Again, here it's front-end. Performance is a feature, so you shouldn't blindly just do what you see here. There are also Chrome developer tools which don't do this great stuff, but still have a lot of information. And then there is Google PageSpeed Insights, which is a server solution, which you enter a URL in the website, and then it fetches the page and gives you a rank, one for the mobile side and one for the desktop side. Then there is Web Page Test. This is actually the tool I have used to generate this massive graphic, and it really gives you a lot of information. For example, here on your right-hand side, you see the bytes. Sorry, here makes more sense. You see the bytes. There are like 77% of all the bytes downloaded for srf.ch are images, which is okay because in a media site there are a lot of images. But we can also see that almost 80% of the HTTP requests are used for images, which are maybe too many. So we could use actually the CSS Sprite technique. But yeah, it's up to our product owner to decide that. All right, now all these tools I have introduced, except actually the Chrome developer tools, are thrown together in Show Slow. Show Slow takes the results of all these tools of web page speed, of Google Speed Analytics, and of YSlow, and you can upload it to their service, and they do a nice graph where you, for example, see your grade of the YSlow over time. Now, this is a great way to, if you changed something in your front-end performance, to really see how this impacted your performance. So yeah, have a look. It might bring you some ideas. All right, now DOM manipulation. First of all, DOM is the internal HTML representation in the browser, which is accessible by JavaScript. Now, if you do something like this, which we do like every day, the browser has to look up the element with the ID MSG in the internal structure. It has to modify the internal structure and re-render at least part of the page. Now, you could think that if you do this very often, it gets very slow. And indeed, it is like this. I will show you an example. So the aim is to save DOM manipulation. The example is on this side. This is an overview of all our shows. We have about 320 radio and TV shows. And there is this big overview page where you can see all the shows. And there is a filtering place, so you can filter either by topic or by station where it first aired. And then we have, for every letter, we have a div, and then we have 2 URLs in it. And the thing is, this is because the sorting is vertically, so it's A, B, C, D, instead of horizontally, not A, B, C, D. So what we did was we had to connect these shows and the filters. What we did is, with the filters, we have the value with this topic, which is the name of the filter, and then the value of the filter. And in the HTML of the letters or of the shows, we have the corresponding topics as data attribute. Like this, we don't need to have any relation or something in JavaScript, but we have everything in HTML. So yeah, we thought about, okay, that's nice. So what we can do is we just get the value of the 2 filters and we concatenate it together. The star equal sign is for the topic has to be part of the data attribute, and jQuery actually handles multiple selectors quite well. And what we then did is we showed all the shows. The list items are the shows, and then just hit the ones which do not match this selector. Now there was a problem with this one. Could anyone think what it was? Yeah. Yeah, but then you need sorry. Then we would have another loading call, which would be always a little overhead. But yeah, we try to work with the DOM we have, with HTML we have. But the problem was this one, that it could be that all the hidden elements were on the left side, and on your right side you have all the matched shows, and this looks a little bit stupid. So what we did is, with the second approach, we first hide all shows, then iterate through the letters, go through every, then clone the matching shows, like DOM, get the clone function from jQuery, and then we append the cloned shows to the left or the right list, because now we know how many elements we have, we can balance them, and then show the cloned shows. So this is how we did it. We first went through the letter, and then we went through all the shows, hided it, then found the matching one, we cloned it, and then we added a class copied so we could re-get it in a later stage, and we appended it to the body. And then at the later stage, we refetched these cloned functions and appended it to left or right, and then showed it. Now this was very slow. It was even so slow that Internet Explorer showed this box. The script is not stopping executing, so yeah, we couldn't do that, of course. So we changed the approach a little bit. What we did is that instead of putting the DOM, the nodes into the DOM, we just had a variable of the shows, and then we cloned the variable, and then we iterated through left or right UL, and then we showed it at the end. So, and this was amazingly very fast. So what's the difference? The second approach was inserting cloned nodes into the DOM and then work on them. And the third approach is do not insert the DOM nodes into, no, do not insert the nodes into the DOM until you really need it. And yeah, that was basically the big performance issue we had. So DOM manipulation may be really a problem for your site. I didn't think that of that. Yeah, I didn't think this would be the case, but yeah, it might be. So yeah, we're already at the recap. So if you think this was really a shit talk, but you still think about performance as a feature, I'm completely fine. Because it really it is the most important point I want to get you across, that performance is a feature. It doesn't, that also means that you don't need your site to be very fast if your client doesn't say, okay, spend this much money or spend this much time in it. And yeah, of course, it doesn't mean that you shouldn't do any performance stuff at all, because it also is really a big portion of how the users perceives your website. Then some technical stuff, put the CSS in the head and the JavaScript just before the closing tag of the body. Put all your CSS and JavaScript in one file, and version your CSS and JavaScript file. Of course, let the browser cache it. And then use tools to measure performance over time. So you can kind of do regression testing, which really helps a lot. Because then you sometimes see that your super feature for performance maybe isn't that good, or you see that something else which you thought might not be an issue is in fact an issue. And yeah, if it's really slow, try to save DOM manipulations. Okay, so can I already go to the questions? If you want the slides, I will upload in a few minutes. Good.
Well, then I start off with a Twitter question from Krasimir Tsonev. He already asked another question early on. This one is about what do you think about server-side template rendering?
Like server-side includes or stuff, or
No, you actually server-side render the templates and then you actually get the template ready already from the backend.
Ah, okay. Yeah, I think that's completely fine. I mean, there are these ideas to have a JavaScript templating language, and I think there are a lot of use cases where you can use them. For example, there is, say, single-page applications like Gmail, or if you have like really a big single-page application. But normally, in like at least the websites I did, yeah, the only thing I used was templates on the server side. So.
Okay, and we got another one from Rodney Rim, one of our speakers. Is there any particular reason SRF is not using Grunt or Uglify.js for the JavaScript concatenation and minification? And what do you think about Require.js?
We're actually using Require.js, and at the backend, we are also using Grunt for the backend. There's actually not like a real big reason. It's just when we started with it, the Grunt wasn't even, I don't know if it was released already. Yeah, but we are actually using UE compressor for compressing our stuff. But yeah, I mean, we could switch to this new fancy stuff.
That's from me from Twitter. Any other questions?
Good, thank you.
All right, then we have about, I would say, what's that, 22 minutes to change the room then. So the next talk will be at 4:30.